Alright, so today we're going to work on solving some division word problems. And we're going to really look at what the numbers represent in the problem, what they mean, and then we're also going to look at what happens when we have something left over or a remainder. So I want you to flip your work mat to the blank side. That way you have plenty of room to work. We're going to start out. These are some easier problems, but I want us to do these easier ones first so that we can really think about what's happening in the problems. Okay, so for this first problem, there are 12 students in PE class separated into 4 equal teams. How many students are on each team? I want you to draw a model to represent that division. There are 12 students in PE class separated into 4 equal teams. How many students are on each team?
That's exactly the question.
How could you draw a model to show that there are 12 students in PE class separated into 4 equal teams? Let's think about our numbers first. What's the total number of students that we have?
12.
12. So we have 12 students total. How many groups are we dividing those 12 students into?
4.
So what operation are we going to be using?
Divide.
Division, of course. So we need 4 groups. Can it just be any size group, or is there something special about the groups?
There's something special. All equal.
They have to be all equal. You're exactly right. And so I'm looking to find, my unknown is how many students are on each team or in each group. So that's going to be the size of my group. Okay? So I'm seeing a couple different models. Let's see. Zyla used squares. And how many squares did you draw, Zyla?
4.
Zyla drew 4 squares. Jaden, you drew circles. How many circles did you draw?
4.
4. Same thing for you, Tommy. Daniel, I'm waiting to see your model. Alright, so in your circles or squares that you drew, what did you do after you drew your four different shapes? What do those represent?
The teams.
The teams. Okay, so then what did you do?
We put the amount that needed to be 12.
You put 3 in there, and 3 plus 3 plus 3 plus 3 is
Okay.
12.
All right, so Tommy, did you start out just with 3, or did you do something different? Did you know it was going to be 3 already?
Yeah.
Yeah. Okay, how did you know that?
Well, because I did 4 and I got like 18 or 16, and then I
Okay.
took away 1 and I got 12.
Okay. Zyla, how did you do it?
I put 1 and 1 and 1 in each
Okay,
one, and then
so you
I
did
kept
like
doing that until I
1,
got 12.
2,
And
3.
then I noticed I could have just put 3 because
Okay.
I wasn't thinking, because 6 plus 6 is 12, so I could have put 3 in each.
Okay, so you just did 1 to each until you got to 12. Until you'd use, and then after you did that, you were like, oh, I should have known that. That's okay. Jaden, did you do it the same way Zyla did?
Yep.
Okay. All right, and Daniel, I see you're drawing your model the same way. So how many students are going to be in each group?
3.
Okay. So how could what would our division problem look like? I think all of us already have it written.
It would look like 4 in the division side and 12 and then the answer.
Okay, how many are we starting with? How many total students do we have?
12.
12. So when we're dividing, we always start with a total. So we're going to put 12 divided by 4. And then what's going to come after that to make it an equation?
3.
3.
What do we need in between the 4 and the 3?
Equal.
Equals
Division.
12 divided by 4 equals 3. Remember, the total that we have always goes first. So 12 divided by 4 equals 3. How could we check our work to make sure our division was correct? What could we do to...
Count it again?
Okay, we could count it again. Tommy, when you counted, you said 3, 6, 9, 12. I remember you doing that when we talked about the model. How could we represent that skip counting?
Because 3 times 3 is 9, and then 3 more is 12.
Okay, so we would be doing 3 times what?
Times
4 equals 12. Yeah, we can check our division by using multiplication. We can multiply the number of groups times the number that we have in each group to make sure that we get the total. All right, let's change that up just a little bit. So again, there are 12 students in PE class, but now 3 students are needed on each team. How many teams can be made?
4.
Okay, how'd you know that so fast, Daniel?
Because it's 12 divided by 4, and that 4 times 3 is 12.
Okay,
3 times 4 is 12.
so this time instead of having 12 divided by 4, this time we're doing 12 divided by 3, but that's going to equal 4 because we know that 4 times 3 equals 12.
Yeah, because we just did that.
Yeah, we just did that one. You're exactly right. So 12 still is going to equal our total. That's the number of students we have. But what does the 3 represent now?
How many students are in a team?
Yeah, that's how many are in each group. That's the size of our group. And then the 4 represents what?
How many groups there are?
Yeah, and the number of groups or teams. Very good. So that shows us that we can set up our division problems, and the quotient or the answer can either tell us the size of the group or the number of groups. We just have to use our problem to figure out which we are looking for. All right, so let's try another one. Erase your work mats. All right. One more student joined the class. Now there are 13 students to be divided into 4 equal teams. Draw a model to find out how many students are on each team. So what's our total number of students now?
13.
13. And we're dividing those 13 students into what?
4.
4 equal teams. So the 13 represents our total. The 4 is going to represent the number of groups or teams. So we're looking for, our answer is going to tell us the number in each group or the size of the group. So here's the models that I'm seeing. Got your 4 groups. We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What happens if I give all 13 students to a team? What happens to my groups?
One of them is not equal.
Yeah, there's one that's not equal. So this first group has 4, and the rest of them have
3.
3. Okay, so How are we going to, what are we going to do about that?
X it out and then the remainder of 1.
Yeah, that one's going to be a remainder. So my answer is 3. I'm going to have 3 students in each group, and I'm going to have a remainder or a leftover of 1. So our quotient or the answer is 3, and the remainder is 1. So what does that mean? That I have 3 what?
3 people
3 people in a team
and 1 remainder.
and 1 that does not have a team. Very good. All right, go ahead and erase your work, Matt. We have another question to solve.
it, but then I just wrote it back.
All right. Christy bought 13 roses. If she puts 6 roses in each vase, how many vases will she use? Will there be any roses left over? Christy bought 13 roses. If she puts 6 roses in each vase, how many vases will she use? Alright, so I'm seeing models that look like this. You made 6 groups. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, but then you had to kick that one out. Let's look at, actually, let's go ahead and look at Zyla's picture that she's drawing. She's drew something that looks like a vase. And what are you putting into your vase, Zyla?
Flowers, and I'm doing like dots.
Okay. And how many are you going to put in there?
6.
6. 1, 2, 3, 4, 5, 6. Then what'd you do when you got to 6?
I drew another vase.
Drew another vase? And started doing it again? 1. So that one more makes 7, 8, 9, 10, 11, 12. And then you're going to have 1 more left over. Okay, because she had 13 roses. So let's look at our problem. Christy bought 13 roses. If she puts 6 roses in each vase, how many vases will she use? Will there be any roses left? What's the total number of roses that she bought?
13.
13. So we're going to write our problem as 13 divided by, what am I dividing those into?
6.
Groups of what?
6.
Groups of 6. Now does the 6 in this problem represent the number of groups or the number in each group?
Number in each group.
The number in each group. So 13 divided by 6 equals 2 with a remainder of 1. What's the difference in the 2 different models? How are the 2 models different? In one we made 6 groups and we put 2 in each group and then had 1 left over. And then in the other we made groups of 6 and figured out that we needed 2 groups of 6 and we would have 1 left over. Which one of those correctly models the problem or the question? If she puts 6 roses in each vase, how many vases will she use?
2.
Yeah, So the correct model that would actually match the problem is the way Zyla did it, right? She made a vase, put 6 in it, made another group of 6, and then realized she would only have 1 left over. Did we get the correct answer by modeling 6 groups and putting 2 in each group? Yeah. So remember back on the very first problem we saw that it really didn't matter. We could solve either way and get the correct answer. You just have to make sure that you pay attention to what everything represents in your problems, okay? All right, erase that and let's try another one. Oh, I got a question about that one. How would we check that? We said 13. We had 13. We divided them into groups of 6. 13 divided by 6 equals 2 with a remainder of 1. How could we check to see if our division's correct?
Calculator?
I don't have a calculator right here.
Calculator.
Work it out.
How could you check it?
You could like you
Math
could
crap.
Okay, that's okay.
do like 2,
Mm-hmm.
4, 6, 8, 10, 12, and then add another
Oh.
1.
So
You get
2
13.
times 6 gets you to 12. That's how many we actually have in the vases, right? And then you said add 1. Why would we add 1?
Like keep 1 out because yeah, I kind of got messed up.
Because we have 1 extra
yeah.
rows, don't we? We have 1 more. Like
Have to have
in
one
that
equal.
in that kid, the problem where there was an extra kid on in the class. Are we just gonna throw that kid away?
No.
Well, no.
No, like keep
We're
him
gonna
to
have to
the
add 'em.
side.
Yeah, exactly. So we have to add that in. Very good. All right, you should have erased your work map. Suppose Christy bought 13 roses and wanted to divide them equally into 4 vases. How many roses will be in each vase? Will there be any roses left over? So I'm seeing everybody's written out a division problem. What does your division equation say, Daniel?
13 divided by 4.
13 divided by 4. How did you come up with that?
Because there's 13 and you have to put them into 4 different groups.
Yeah, so we've got 13 roses. That's our total. And this time, when I'm dividing that 4, is telling me the number of groups because she wants to put them into 4 vases. So I'm going to be looking for the size of the groups or how many will be in each vase. Jaden, what did you come up with?
I came up with 3 with a remainder of 1.
How did you come up with 3 remainder 1?
I just put 1 until it equaled 13.
Okay, so how many groups did you make?
I made 3.
Did you make 3 groups or did you make 4 groups?
4 groups.
You made 4 groups and then you started putting 1 in each group?
Mm-hmm.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then you knew that you would have 1 extra. Zyla, I see you're writing some numbers down underneath yours. Can I count or skip count by 3s to figure that out?
Yes.
Okay. 3, 6, 9, 12. How many 3s does it take to get as close as I can get to 13?
4.
4.
4.
Okay. And that's the number of groups. Could I skip count by 4s?
Yeah.
Okay. How would that sound?
4,
4,
8, 12.
4, 8, 12. And that took how many?
3.
3. We know that 3 times 4 equals 12. And then if I wanted to check, I know I need to add my 1 remainder, and that gets me
13.
to 13. All right, go ahead and erase. This is going to be our last one.
can remember 3.
Okay, Allison has 22 meters of fabric to sew dresses. She uses 3 meters of fabric for each dress. After how many dresses will Allison need to buy more fabric? Allison has 22 meters of fabric to sew dresses. She uses 3 meters of fabric for each dress. After how many dresses will Allison need to buy more fabric? We talked about that skip counting strategy earlier. So let's see if we can skip count.
2, 4, 6.
So what are we going to skip count by this time?
2.
We're going to skip count by 2s?
Mm-hmm.
Let's talk about our equation first. What's the total amount of fabric she has?
22.
22. And what am I dividing that 22 meters into? Sections of 3. So our problem is going to say 22 divided by 3. So what am I going to skip count by if I'm dividing by 3? Yeah. So that would sound like 3, 6, then what?
8.
9, then 12, then 15, then 18, then 21, and after 21 we would get to 24, but I don't have that much, do I?
No.
So I know I can't make that last dress. So the question said, after how many dresses will Allison need to buy more fabric? So I'm going to count the number of 3s. There's 1, 2, 3, 4, 5, 6, 7. So how many full dresses can she make? 7. And how much fabric is she going to have remaining or left?
Need your attention on the playground. I need Stormy Eford.
You're exactly right. She's going to have 1 meter of fabric left. So after she makes her 7th dress, then she's going to have to buy more fabric. All right, very good job today.